Let's take a look at the worksheet for section 5.4. We're going to multiply these two monomials. And so we're going to multiply the coefficients, and then we're going to multiply the variable expressions that have the same base. So x squared gets multiplied by x cubed, y times y to the fourth, and z cubed times z to the fifth. And what we have to keep in mind is that y is really y to the first power. So there's an unwritten 1 on a variable that has no exponent. There's an unwritten exponent of 1. So we want to show at least 2 steps of work before our final answer. So this first step was just rearranging. We can multiply in any order. The next step, we're going to multiply the 2 times the negative 6 to get negative 12. And we're going to show that we're using the product rule of exponents. So x squared times x cubed is x to the 2 plus 3. Y times y to the fourth is y to the 1 plus 4. Z cubed times z to the fifth is z to the 3 plus 5. So we have negative 12 times x to the fifth times y to the fifth times z to the eighth as our final answer. Okay, the next problem, we're multiplying a monomial times the polynomial x cubed minus 5y squared. And here we're simply going to be using the distributive property. So we're going to be multiplying negative 3x cubed y squared times x cubed. We're going to subtract from that. I'm copying this subtraction sign. Negative 3x cubed y squared times 5y squared. And notice the negative in front of the 5y squared is right here. Alright, so we want to show at least 2 steps of work before our final answer. So we've just shown one step. Let's rearrange things in our second step. And a double negative is a positive. So let's take care of that double negative. Let's multiply 3 times 5, and then x cubed times y squared times y squared. So we have negative 3 using the product rule of exponents, x to the 6 times y squared plus 15 x cubed times y to the fourth. So when I multiply y squared times y squared, that's y to the 2 plus 2. And this is my final answer on this one. Alright, here let's look at multiplying 2 binomials. Now one way you can look at this, the x of the first binomial has to be multiplied by the second binomial. And so does the negative 5 of the first binomial. It also has to be multiplied by the second binomial. So x times x minus x times 4 minus 5 times x minus 5 times negative 4. So x times x is x squared, minus x times 4 is minus 4x, minus 5x. A negative 5 times a negative 4 is positive 20. So I wind up with x squared minus 9x minus 20. And you may have noticed that these products that I computed were the product of the first terms, x times x, product of first, x times negative x times 4 is the product of the outside terms, negative 5 times x is the product of the inside terms, and negative 5 times negative 4 is the product of the last terms. So you don't have to think of it as FOIL. Really, you're just using the distributive property twice. If you like the ideal of FOIL and it helps you, then use it. All right, here we need to multiply the polynomial x plus 1 times the polynomial x squared minus x plus 2. And we're going to use the distributive property. The x, the first term of the first polynomial, has to be multiplied by every term of the second polynomial. Positive 1 from the first polynomial has to also be multiplied by every term of the second polynomial. And here I'm just using the distributive property. X gets multiplied by x squared. I subtract x times x. I add x times 2. And it may help for me to kind of color code this. And then let's put this 1 in blue. So I also need to multiply this positive 1 times every term of the second polynomial. So notice I have x cubed minus x squared plus 2x plus 1 times x squared is simply x squared, minus 1 times x is just minus x, plus 1 times 2 is just plus 2. So we want to combine like terms, and x, there's only one x cubed term, so I recopy that. But I have minus x squared plus x squared. So those are going to add to 0. And I'm going to show that by drawing a slash through those. Plus 2x minus x is plus x. And then I simply add the plus 2. So that would be my final answer on that one, where I multiplied a binomial times a trinomial. Notice that it's really just using the distributive property twice. All right, now I want to multiply 3 binomials. And I'm going to do that by multiplying 2 at a time. So first I'm going to multiply x minus 2 times x minus 3. Actually, I could do it that way. There's many ways I can do this. I'm going to choose to multiply x, leave x minus 2 out of it for a moment, and I'm going to now multiply x minus 3 times x plus 4. And I could have done x minus 2 times x minus 3 first. So when I do this product, I'm multiplying x times x plus 4. And I'll color code this. And then minus 3 needs to be multiplied by x plus 4. So notice how the x minus 2 is just getting recopied at every step. So I'm going to have x multiplied by x added to x multiplied by 4. And I'm going to have minus 3 multiplied by x, and minus 3 is also going to be multiplied by 4. So I have x minus 2 times x squared plus 4x minus 3x minus 12. So x minus 2 is multiplied by x squared. 4x minus 3x is x. So x squared plus x minus 12. And now, in order to carry this out, I've got to make sure the x and the minus 2 get multiplied by each term of the second polynomial. So I'm going to multiply x times the second polynomial, x squared plus x minus 12. And I'm going to multiply negative 2 times that polynomial as well. So notice each of these three terms, x squared plus x minus 12, gets multiplied by x. And in the second situation, each of these three terms gets multiplied by negative 2. All right, so let's see what happens. X times x squared is x cubed. X times x is x squared. Minus x times 12 is minus 12x. Minus 2 times x squared is minus 2x squared. Plus minus 2 times x is minus 2x. Minus 2 times minus 12 is plus 24. So we'll combine like terms. There's only one x cubed term, so I recopy that. But I have x squared minus 2x squared. So that leaves 1x squared minus 2x squared is minus x squared. Minus 12x minus 2x is minus 14x. And then I add 24 to get my final answer. So notice how I worked with two polynomials at a time. And I could have either worked with the first two polynomials and then brought in the last polynomial, or as I chose to do, I worked with the last two polynomials and then brought in the first polynomial. The results would be the same. The final answer would be unchanged. All right, so this is our worksheet for section 1.4.